Here we want to identify which of the following functions or equations this table represents. Does it represent the linear equation? Does it represent the quadratic equation? Or does it represent an exponential equation? So the good rule of thumb is to go through the linear test and then the exponential test, and then when both of them fail, if they both fail, then it must be the quadratic. And I'm not giving you the neither choice here, so it's definitely going to be one out of these three. Of course, there are possibilities that it could be neither, but in this problem, I'm going to tell you it's one of these three. So we're going to have to check. So with the linear, it's the most straightforward test. We know that for every increase of the x, as you can see, the x increases steadily by 1 each time. We should have the same increase of the y. So as you can see here, the increase of the y is how much? It's going to be precisely 63, right? 81 plus 63 is 144. But here the increase is not 63, right? Because 144 plus 81 is precisely 225, right? So that should tell you this is not linear, right? Because these two numbers, these two increases for every x are not the same, right? So we can cross that out. Now let's check the exponential, using the exponential. So we know that this b here is the factor responsible by transforming a given number into the next number, right? So we multiply the b, the factor b, with 81, we should get 144. And the same thing should happen with 144. We multiply the b by 144, we should get to 225. So let's find the b using these two numbers. So we know that 81 times b should be equal to 144. And then we can find that factor. Okay, we can find that factor. And let's see. So if we divide by 81, the b will equal to 144 divided by 81. So now we're going to apply this value of b to 144, and let's see if we multiply this by 144 if we get 225. If we don't, then this test failed, and this is not an exponential equation either. Right? Then by default, it will be quadratic after that. So let's test that. So 144 times the factor, 144 over 81, should give us theoretically 225 if this is exponential. Now, is it 225? The way you can test this mathematically easily is to see that 4 times 4, the outer numbers here, 4 times 4, the last digits, will give you a 6 as the last digit, right? Because 4 times 4 is 16. Now 6 divided by 1, right, divided by 81, will give you 6, right? And you can test that using your calculator. Divided by 81, the last digit will be 6. And I don't care what it is. I know that the last digit is 6 of the resulting number of this product, and it's definitely not going to be 225 because the last digit here is 5. Right? So this is no way going to be equal to 225. So by default, this is the only equation that is satisfied by this table. So this goes out. So now, how do we find this equation? Now that we've identified that this is a quadratic equation, how do we find it? Well, let's actually use the x values and the y values and to create 3 different quadratic equations so that we can solve for a, b, and c. Right? So the first equation, I'm going to label it equation 1, is going to be 81, because this is the y value, 81. I'm just going to use these two. This pair, this ordered pair, 3, comma 81, we're going to have 81 equals to a x squared. X squared is 3 squared, so I might as well just write 9a. Plus, now b is what? We're going to have to find it. X is 3, right? So 3b plus c, right? We don't know what the c is. Now let's formulate the equation 2. We're going to use this ordered pair now, right? So 4 squared, so, well, let's find the y first. 144 is equal to, this is going to be squared, so 16a. 4 squared is 16, so 16a. Now, 4 is the x, so plus 4b plus c, right? Notice that the c will never change because it's by itself. There's no number besides the 1 attached to it, so we don't know what it is. Now the final equation is 3. Now why do we need 3 equations? We need 3 equations because we have 3 unknowns, a, b, and c. There's no way you will find 3 unknowns with only 2 equations. You need exactly 3 equations for that. Okay? So equation 3 will be using this pair. So 225 is the y value, is equal to 5 as the x being squared, so 25a. B is, x is 5, so plus 5b plus c. So now we need to eliminate, as you can see, it's very easy to see that we can take any pair of 2 equations and basically subtract one from the other, and we will eliminate the c. And we need 2 such pairs in order to get rid of c and only have a and b remaining. Because if you have 2 equations with 2 unknowns, you will be able to solve for a and b once you eliminate the c. Right? So how's that going to work? We can do equation 3 minus equation 2. Right? So we're going to do this minus this, and then the c's will be gone. And then we can also formulate the second equation with 2 unknowns only, a and b, by doing equation 2 minus equation 1. Right? So these are the 2 operations that we should complete. Right? So equation 3 minus equation 2. So what is that going to be? And as you know, each side will subtract the other, right? You're not going to subtract this side from the left side, right? You're going to keep the sides to themselves, right? So equation 3 minus equation 2 is 225 minus 144. And that was what? That was 81 precisely. So I'm going to label that equation 3 minus equation 2, right? So that's 81, 225 minus 144 is equal to this side minus this side, right? So 25a minus 16a, notice that I'm using like terms, which I should. That would be 9a. 5b minus 4b is just b, and then c is gone. C minus c is 0. Great. Now the last one is equation 2 minus equation 1. Equation 1. So what is that going to be? Equation 2 minus equation 1. So this number minus this number is exactly 63. And this side minus this side, 16 minus 9 is 7, right? So 7a. 4 minus 3, that's just b. Making sure this doesn't look like a 6. And then that's it, right? C's are gone. Good. So now, as you can see, this will be so much easier to solve because now you can subtract the second equation from the first equation, right? Because that will eliminate the b's, and that will make sure that 81 minus 63, you don't want to get a negative, so you don't want to do 63 minus 81. You want to do the first equation minus the second equation, right? So as a result, this will be, I'm going to label that. So this is going to be equation 1 minus equation 2. We'll eliminate the b's and we'll solve for your a's. So 81 minus 63, that's going to be 18 on the left side. And on the right side, 9 minus 7, that's going to be 2a. And then b's are gone. Good. So now you divide both sides by 2. A is solved for. So a is going to be 9. So once you find the a, it's easy to find the b, right? Using any one of these 2 equations. I prefer to use, well, it really doesn't matter. It's the same thing. Well, actually, this one's easier because 9 times 9, 9 times the a is 81. There's already 81 there, so b is 0, right? Because 81 is equal to 81 plus 0. Otherwise, it's not going to be 81. So b should be 0. Now, once you find a and b, it's going to be easy to find the c. The easiest equation is the first equation because the coefficients are the smallest for the a and b. Right, so let's find the c value. So 9a, so 9 times 9 plus 3 times 0, the b value, plus c. So as you can see, it's the same situation as it was with the b, because we already the only non-zero is this one, and that's 81, right? Equal to 81. So that means everything else besides the b should be 0. So c must also be 0. C must also be 0. So now we found our equation, quadratic equation. So the equation is y is equal to a value is 9, so 9x squared, and that's it, right? Because the b is 0 and c is 0. And if you test that, you will see that this equation satisfies the ordered pairs, every ordered pair. So if you test the every single x, your y value will be correct. It will match the table. So if you put in 3 here, you will get 9. 9 times 9 is 81. Bingo. If you put in 4, 16 times 9. 16 times 9 is 144. If you put 5, you will get 25. 25 times 9 is 225, etc. Right? The 6, 36 times 9, 324. 49 times 9 is 441. All right, so I hope this was fun and helpful. Thank you so much for watching. See you in the next video.